Sweet. All right. Hey everyone, my name is Catherine. Today I'm going to be talking about lessons learned from building fast infrastructure for AI agents to access the internet. I'm the co-founder and CEO of Kernel. We've been around for just over a year. Right-hand side is some of the folks on our team, San Francisco based, but we also have folks in Cincinnati, New York, Seattle, LA, and Denver, so a little bit distributed. And we really got together a year ago to be 100% focused on building the infrastructure layer that gives agents access to the internet via a browser. What that really means in practice is we are doing sandboxed Chromium and providing an API for developers or agents to easily grab that browser and then do whatever they want on the internet. That could be things that don't have APIs, that could be checking the docs, the latest Vercel docs to see like how to use the new SDK, and we give the developer the ability to like create a browser and access it in all these different sorts of ways. So you can connect to it over CDP. You can use our computer use API if you have like a CUA loop going. You get to select like headless versus headful mode. And then we also solve all the stealth problems for you. So it has like an auto CAPTCHA solver on it. We can like pipe it through residential proxies. All of that are kind of like fairly simple configs that you get to use on demand. And the reason that we are so focused on just that infrastructure layer can be pretty easily summed up from this quote from Jeff Dean. He said, agents are interacting with our environment using tools that were designed for human scale interaction or human speed interaction. And it's very much like what they just said in the previous presentation, which is like, if you look at the sheer volume of things happening in any infrastructure platform today, it is more than 10x, more than 100x, it's more than even 10,000x. GitHub, of course, is kind of notoriously struggling to maintain any nines in its uptime right now. But that's not to say that it's GitHub's fault. It's that it was built in an era that like didn't see that level of scale before, and that is not an easy problem to solve. The right-hand quote is from the COO of GitHub, and he said, there were 1 billion commits in 2025. Now it's 275 million per week, on pace for 14 billion this year if growth holds steady. And so like that's the level of scale that agents are changing the infrastructure requirements, and it's kind of why we decided to like be super focused on just this one problem and not do anything else. And so even though we've only been around for a year so far, we've already iterated on our infrastructure a few times, and that's what I'm going to walk you through today. Starting out with Docker containers, putting Chromium in Docker, then our second implementation in Unikraft Unikernels, and then our most recent implementation, which is a fully owned control plane that can spin up browsers in different types of VMs, including QEMU, Cloud Hypervisor, and Firecracker. So our first implementation was kind of the most obvious implementation that you would do if you were to put a browser in the cloud, which is you might put it in a Docker container. If you've ever done like a Selenium test in a CI/CD pipeline, that's kind of like the same process of what we were trying to do. The main issue with this implementation, aside from the security boundaries of Docker containers, is that Chromium takes up a really long time to start, anywhere from 10 to 40 seconds. And so, on a single run of a CI/CD pipeline, that's totally fine. But if you need like tens of thousands of browsers in the order of a few minutes, like that becomes a pretty intractable problem. But I think like, okay, like I'll do warm pools. They'll probably solve the latency problem. But then of course you quickly run into the fact that like that is really cost ineffective. And the second problem is that agent workflows uniquely are long running. And an agent accessing the browser the same way that you or I access a browser on our local computers might want to come back to that state, minutes later, hours later, even days later. And so if you're doing that just with warm pools of Chromium browsers, it's just not a tractable problem. It's going to continue ballooning at a level of scale that's not really feasible. And so that's when we pivoted to our second implementation, which is putting Chromium on Unikraft Unikernels. Unikraft Unikernels are a fork of Firecracker VMs, and the unique property of the Unikernel is that they can do standby and resume very, very fast. And what that means is you can spin up a VM with its state and then very easily put it to disk. And when it does, it basically consumes 0 CPU or memory. And what we do with that property is we actually decouple the launch of Chromium from the runtime request of a developer, an agent asking for a browser via API. So in the background, we might be spinning up Chromium browsers, eating that full 10 to 40 seconds, and then we'll write them to disk. And then when someone requests a browser from our VM, we'll just wake one back up, and that's how we deliver it in 30 milliseconds or less. So both of our images of our first two implementations are open source, so come check them out if you're interested. You can self-host either of those, and yeah, that's kind of how it got started. More recently, in the past few months, we decided not to stop there. There were a few things that we were really interested in solving next. One of the main issues with the Unikernel approach is that kind of by design, they pin the VM to a single host. And that becomes really a not great, that becomes pretty intractable in production. So if one of our bare metal instances goes into a degraded state, we can't easily live migrate that to a better host. So we just basically lose that VM. The second issue, or the second opportunity that we were really to build around was we wanted to be able to connect GPUs to our browsers via either GPU pass-through or vGPUs. That would enable things like canvas-based websites to load really smoothly on our browsers. We also we're noticing that some users were running into OOMs because they were maybe doing their agents were doing infinite scrolls and it was just consuming way too much memory. And Unikraft Unikernels or Firecracker VMs, broadly speaking, don't support device pass-through for GPU support. That's mostly a function of the way that they were designed. They were designed for fairly stateless applications. They just weren't really designed for the full feature VM support that gives all the fancy things that we would want on our browsers. And so we started building out this control plane that we call Hyattman. And it powers, it is a single control plane that can manage VMs on Cloud Hypervisor, Firecracker, and QEMU. And we were able to implement our GPU accelerated browsers on QEMU VMs. And what that means is that we're still able to deliver really, really fast cold starts for the end developer. So we generally benchmark 6 times faster cold starts. And just by optimizing the infrastructure performance layer, developers will see up to 4 times end-to-end speed of their agent using our browsers over other implementations of the same thing. And the other cool thing is all the interesting, oh no, is it not? Oh, there we go. Yeah, no, this is not looking like how it's supposed to be looking. I'll show you on my computer, which is with the GPU accelerated browser, we're able to get this really buttery smooth on the left-hand side, WebGL aquarium benchmark. The right-hand side, you see the 10 frames per second, and it is much choppier. Unfortunately, the presentation makes it look like the same. Let's see if the next one goes. The other experimentation we did when we were benchmarking our GPU-based browsers was we tried to play Doom on it, and it ended up turning out pretty good. We're getting about 60 frames per second on our GPU browsers. Our CPU-only browsers get about 10 frames per second, so we were really happy with that performance. And that's all I have. Thank you so much for listening to my talk.
Are there any questions? I think I'll start with one question, which I think I asked earlier as well, which is, I think for sandboxing, there's kind of been a third-party benchmark like OpenCompute, where you obviously are competing on, time to first start. Has there been anything like that for, browser as an API?
We were just talking about this. The main one that we look to, which is open source, is called BrowserBench. That's an open source one done by a third party in the browser space.
Mm-hmm.
Yeah.
Okay.
Yeah.
What are like some of the most interesting use cases that you've seen, like folks who use you for it because of all the speed and performance improvements?
Yeah, we a few ones that I like personally love. We serve a lot of like health tech, insurance tech companies. So they're automating back office processes that don't have APIs and generally running pretty deterministic workflows. But what's cool is you see them building their platforms in different ways. So like certainly nobody's writing their own Playwright scripts. A lot of them are using LLMs to generate Playwright and then like running the Playwright until it breaks and then using an LLM to self-heal. We've even seen like some use cases in that world where they are using like Kua loops pretty successfully. And then another use case that I really like is we're starting to finally see consumer platforms. We were looking at a user today who is doing like an AI trip planner, which is like the canonical example that people have always been talking about for browser agents, but like the technology wasn't there. The stealth mode like gets in the way of a lot of issues. And I think that like with kernel solving the stealth issues and then the models actually being good enough, fast enough to like reliably click around things, I think we're like going to start seeing that more and more over the next year. And I don't know. There's like a lot of like QA is a big one that we QA agents. Yeah.
Because I feel like that's probably the biggest pain point that folks have is like end-to-end testing a long time in CI.
Yep. So yeah, growing number of like just various QA agents. Even like QA like live websites is pretty common. So Cash App uses kernel to QA partner websites for like presence of like brand conformance and stuff like that. Maybe the last one I'm excited about is e-commerce, agentic e-commerce. So we have a customer that provides a single API for all checkout, 100% coverage for any website checkout. And they do that in a variety of ways. And then like some of the ways, if they don't have like a partnership with that platform, like they might certainly like first party integrate to Amazon, but like for the vast majority of long tail of sites that like they can't partner with, they'll use a browser agent to like do the end-to-end experience. That's pretty cool. Yeah.
Did I hear correctly that you're saying you also like do CAPTCHA solving as well?
Yeah, so our browsers, you can turn on stealth mode and then it'll solve reCAPTCHAs, Cloudflare turnstiles. We're currently prototyping an HCAPTCHA solver.
Okay. I'm curious if that like ever got you in trouble with anyone.
Well, part of being a somewhat small startup is we fly a little under the radar. I think like it is going to be increasingly a problem, a business challenge that we'll have to like address as we can like become more and grow more and more scale. I think it's very related to a broader problem in the ecosystem, which is like, websites being fairly antagonistic to bots or agents, and like, how do we make that shift to like, there are like good agents or at least like permissioned agents on someone's behalf that are taking action, and like, can they be distinguished from, DDoS attempts and bad actors? And if so, like, what does that protocol look like? And so we also have like products that aim to start to solve that problem. One of them is called managed Auth, and it allows essentially like a consumer to designate like their credentials for a given website to an agent on our platform. And that is like the first step that we believe we can take to then eventually say to the website, like, oh, like Gabe's agent is going to this website and like he's given the agent permission. So like it should not be bot detected. Whereas, maybe this other one that no one knows about should be. Yeah. But it's a great, certainly like a not trivial, like business and technical challenge that in our space for sure. Yeah.
I was wondering if you could talk a little bit about how the LLMs control the browsers, and if you had any tips around like which LLMs maybe are better at it, or what tools you've developed in-house to handle that.
Yeah, we do. So an LLM can connect in two ways. It can either connect over CDP, so like an LLM can just generate Playwright and execute Playwright against a kernel browser. We also even have like an API called execute Playwright, and so like you don't have to run that Playwright script anywhere else, locally or on a Lambda. Like you can literally just send the instructions to the kernel browser, and then we'll execute it against the VM. Or you can use, we have something called a computer controls API, and it basically allows you to send like click coordinates to click, type, move the mouse on. And like computer use models, cloud computer use and OpenAI's computer use models have been trained to like be able to take a screenshot and then like given the viewport, figure out where to click next based on what it wants to do. And so like you could, if you like, you can download the kernel CLI, and give it to Claude Code today, and be like, open up 3 browsers and do like these 3 tasks in parallel on different browsers. And Claude will know to just like take a screenshot and then figure out where it wants to click, where it wants to move the mouse. And it's good. I would say like, you know, the technology, the model itself is like, a year ago was like slow and like didn't work. Now it's like slow and like works. It's just, I think like definitely gonna get better and better on its own. We also like use skills a lot internally. And so like we might just, you know, like I have like a skill on my local where it just like knows how to use the kernel CLI better. Or like we might see people do like website specific skills. Once it figures out how to do it the first time, give it that skill and then it can do it faster the next time. We're very bullish on like skills as like a lightweight way to nudge the model into being like more efficient with its usage. And yeah, did I answer all your questions? Yeah. We also have like 2 skills on our docs. One is actually neither of those skills are like particularly useful for making computer use faster or better. One is a bot detection skill. So if you ever want to be like, why is this website being bot detected? This skill will do the analysis for you, and it'll tell you like, oh, it's this provider, and if you use like these combinations on kernel, like it should, like we think it should have a higher rate of passing. And then the second one we have is more for debugging state on the browser.